Here we have a question 2 that says a 600 Newton force is applied horizontally on a block of mass m kgs by means of a massless inextensible rope. The block remains stationary when the angle that the rope makes with the horizontal is 30 degrees. Now remember that to start off, you need to choose what your central point is. So there's going to be a point that experiences all the forces. And in this case, it is going to be this block M. So this block of m kgs is our central point, and these are the forces that it experiences. Since it has a mass, it will experience the force of gravity, which we know always acts downwards. There is a force applied of 600 newtons going to the right. And we also have tension at an angle. So these are the three forces that block m kgs will experience. Now 2.1 says, explain why the block is stationary. So the reason why the block is stationary, and we know this kind of situation that we have is where the system is in equilibrium. Now what does that mean? It means that the net force acting on the system is 0 newtons. So that is why the block is stationary. There we have it, the net force acting on the block is 0. Now question 2.2 says, use either a calculation or a construction to determine the tension T in the rope. Now if you are going to construct, what exactly are you going to do? You will have to create a closed vector diagram, which is going to be a triangle. And here they want you to use a scale, which is 1 centimeter is equal to 100 newtons. If they give you an option between doing a calculation and drawing a diagram, it's always best to go with the calculation. So that's what I'm actually going to do. I'm going to use a calculation. But before I do that, I just want to remind you that you have been given tension that is at an angle. So if you are going to use a calculation, yes, we will use Newton's second law, where we use F net is equal to ma, but that tension at an angle will have to be broken up into components. So breaking it up into components, we have Tx pointing to the left and Ty pointing up. So those are our horizontal and our vertical components. Now, since we need to solve for tension, we need to see which direction would be easier for us to work with. So horizontally in this case should be a lot easier since if you choose to work horizontally, you have Tx going to the left and you have the force applied to the right. So it's a lot easier to make T the subject of the formula. Now, since we have a choice here, we could either work horizontally or vertically. But it would be a little difficult to work vertically here since you do not know what the mass of the block is. So I'm going to work horizontally, and to show that I'm working horizontally, I'm going to say F net X is equal to ma. So just so that the marker knows you're working in the horizontal direction. Now remember that when you are adding forces, they are vectors, so we generally take right as positive, left as negative. To the left, we've got the x component of tension, so that's negative Tx. To the right, we have the force applied. And since the system is stationary, that means that acceleration is 0. So the right-hand side is 0. In the next step, I'm going to further expand. We know that Tx is T cos theta. And then we have force applied. Now let's substitute. So here's the thing. When we substitute, we are making T the subject of the formula. So we're solving for T. But at the same time, we need to substitute a value for theta. So what is our angle? If we refer back to the diagram, and this is extremely important, when it comes to working with components, it is best that you use the angle according to the butterfly diagram from trig. So if you had to think of this in terms of a triangle, where if I look at it as the triangle having this shape to it, this is the angle that I'm going to go with. So according to my butterfly diagram from trig, And remember, this is what your butterfly diagram looks like. It shows you the orientation of a triangle in each quadrant. So if we take the triangle like this, these are the angles that we need to work with. So right now, this shape that is formed here, this triangle that we have, is a triangle according to the second quadrant from the butterfly diagram. So the angle that we use needs to be in this corner. But looking at the angle that's given to us, we have 30 degrees. So from analytical geometry, or even Euclidean geometry, you know that, so I actually covered more in Euclidean, you know that this forms a Z or an N shape. So this is going to be alternate angles. So the angle that we need is 30 degrees. Notice the Z shape that it forms, so those two angles are equal to each other. So when we use cos theta, it's actually going to be cos 30 degrees. So here's our substitution. We have negative t cos 30 plus 600. So to work towards getting t as a subject of the formula, let us take the 600 over to the right-hand side. It's going to be negative 600. And the last thing that we can do to get t alone is we can divide both sides by what we don't need on the left. So actually what we don't need here is the negative and the cos 30. So we have t is equal to negative 600 over negative cos 30 degrees. Now let's put that on the calculator and see what we get. So I get 692.82 newtons. So that's it to 2 decimal places. This is the tension that acts on this block m kgs. Now 2.3 says calculate the mass m of the block. So here it would be ideal if we work with our vertical forces, seeing that m is used to calculate Fg. Since we're going to work vertically, we are going to work with F net y is equal to ma. Now generally we take up as positive and down as negative, so we will have a positive ty and a negative Fg. And remember, the right hand side is going to be 0 because the system is stationary. Now expanding, ty is t sine theta, Fg is mass times gravity. Let's now substitute. We had just calculated tension as 692.82. The angle is 30 degrees, so we have sine 30 degrees minus m. Remember, m is your unknown and gravity is 9.8. So we're going to simplify. I'm going to put this first term on the calculator. So I get 346.41. Simplifying my second term, that can actually stay as is. What you actually can do is, since you want to solve for m, we would like that term with m to be positive. I'm going to take it over to the right hand side. So that becomes positive m times 9.8. Now to get m alone, we're just going to divide both sides by 9.8. So we have 346.41 divided by 9.8 is equal to m. Let's calculate and see what we get as m. So I get 35.35 kgs. And that is our final answer. Please remember to like, subscribe, and turn on your notifications for more content.